So the last way is called, it's called multiple things. Some people call it combination, or just some people just call it addition, subtraction. You know, if you see either of those ways, they're the same thing. Like, and oops, sorry. Basically what you're doing is you're combining your equations, you're adding or subtracting them together to solve for them. Okay, that's why it's called this, right? So let's say we have the two equations here are okay, so these are our two equations. So I'm going to combine them to cancel out one variable. Okay, so what that means is I like to line them up, so I make sure my x's line up, my y's line up, because then I'm going to kind of treat this like a big addition problem. Because if we add them together, what happens when I add 3y plus negative 3y? They cancel each other out, right? So I added the two equations like a one big addition problem. I'm going to carry down my equal sign still. And then you add straight down, so 7x plus 5x would give me 12x. The 3y minus 3y just cancels out, so it's just 0, so there's nothing there. And then 25 plus negative 1 is 24. But as you can see, I got rid of one of my variables. I got rid of the y. And because of that, now I can solve for x. Right, so I just solved for x. I combine them together, solve for x, but then again, we still remember the answer is a point, x comma y, so we have to solve for y. But I know what x is, so I can just substitute it in. You can pick any equation. I'm going to pick the first one. So I'm substituting 2 in for x in the 5x plus 3y equals 25. That way I can solve for y, right? Minus 10. Right, so I get y equals 5. So my answer is 2, 5. So that's the point where the two lines intersect. Yeah, and this is the addition, the combination, the addition subtraction method. Right, so we're just going to do a few examples. So the first thing I like to do when I'm trying to figure out how I want to combine is I want to think which two variables have the same coefficient. Do you remember what a coefficient is? It's the number in front of a variable. Right, so 4 is the coefficient for x, and this one, 9 and 3 are for the y variables, right? So the two 4x's have the same coefficient of 4. That means I can combine them in a way to get rid of them, right? But, so remember this is called the addition subtraction method. You have to use your discretion to determine should I add or subtract them together. So if I add this together like I did in the previous problem, I'm not going to cancel any variables out, right? 4x plus 4x is just going to give me 8x. Right, and then 9y plus 3y would give me 12y, right? So addition's probably not going to be the best one for this one. Subtraction, on the other hand, if I do 4x minus 4x, then they're going to cancel each other out, right? So we're going to be subtracting. The only thing that's tricky with subtraction, people will write the subtraction in front of the 4x, but you have to remember you're subtracting all across the board. So like I always just write my subtraction in between each one, just so that you remember. Okay, so the 4x's will cancel out. Then you have 9y minus positive 3y, right? So that gives you 6y. And then you have 75 minus 33, which leaves you with 42. Oops, sorry, my things shifted as I was writing. Right, so we just solved for y. I cancel out the x's, which meant I could solve for y. So now I have to plug this into, I'm going to pick the second equation to plug it in, just because it has smaller numbers, but you can pick any one you want. Oops. Why does it change on me? Okay, so I'm just solving for x here. Okay, so I've got my x, I've got my y, so my answer is 3, 7. Okay, so it's called, addition subtraction method, because it depends, you have to use context. You have to look at your problem to determine, should I add to get rid of a variable or should I subtract to get rid of a variable? Okay, but otherwise, hopefully that's pretty straightforward. You're going to combine them so that you can get rid of a variable and solve for the other. Okay, what happens if you have two equations, but none of the coefficients are the same, right? We can't cancel out 5x and 3x, right? We can't cancel out 4y and negative 2y. So we have to kind of get a little creative here. You have to remember about transformation. Right, how if I do something to one side of the equation, I can do it to the other. So try to find the ones with like a common factor. So 4 and 2 have common factors. So what that means is, what if I just multiply this second equation by 2? Right, so I'm going to rewriting this down here. 2 times 3x is 6x minus 4y equals 52. But now if we look, I can cancel out the plus 4y and the minus 4y. So I'm going to completely rewrite it. Oh, darn it. So I'm keeping my first equation the same. The second one I transformed, but that way I transformed it in a way so that I can cancel out my two variables, my y variables. Right, and yeah, so I would be addition, right, because it's 4y plus negative 4y, that cancels out to 0. And then that gives me 11x, and this gives me 66, right? Right, so, and then now I can solve for x. And then I have to just plug it in to any of my other two equations. 5 times 6 plus 4y equals. So I'm going to solve for y. So I get y equals negative 4. So my answer is 6, negative 4. Yeah, so you can transform one of your equations so that you can like cancel out the one of your variables. And so let's just do one more like that. Okay, so I have 7x and 2x. I can't add or subtract that, right, to get rid of one. 6y and negative 3y, I can't combine that in any way to get rid of the variable. So again, I'm going to have to transform. I like to find the one where I can just multiply by one number and it will make it transformable, right? So the 3 and 6, if I just multiply 3 by 2, I'll get 6, right? So again, we're going to multiply this whole equation by 2. And I'm going to just rewrite them this way. And then I have 4x minus 6y is 10, right? And then now I can add them together. Oops. Don't forget to multiply both sides by 2. I forgot to do that. So x equals 2. Now I'm just going to plug it in. I'm going to plug it into the second equation just because the numbers are smaller. Don't forget that negative. Okay, so my answer is 2, negative 2. Okay, so that's solving by combination, addition, subtraction. And then you learned how, like, if none of the coefficients match, you can always transform. You can even transform both equations if you wanted to, or if that becomes necessary, right? So hopefully this makes sense, though. So we learned all the ways to solve systems of equations by both graphing and then substitution and combination. So those are like the 3 main ways. Now we're going to move on to systems of inequality.